In this video, we are discussing the continuation part of light reflection and refraction. Okay, what is that continuation part here? We are discussing about the sign convention for spherical lenses. In my last video, I discussed about the ray diagrams, how we can write the ray diagrams in the case of lenses by taking the objects at different places, right? And here this sign convention, whatever the sign convention that we are discussing for lenses, it is same as that of for mirror. Whatever I have explained in the case of mirror, the same thing will be applied for lenses also. Okay, see, for example, if I take convex lens, as we know the convex lens function is converging, right? It will converges the rays. So for that, if I take a convex lens, okay, convex lens, and it has optic center O, right? And the line that is passing through the optic center is called to be the principal axis, correct? And whatever the conventions that we are writing towards the right side of me is taken to be positive, and whatever the measurements that we are measuring from the optic center towards the left is taken to be negative. But here in this case, the object is always taken to be left hand side, right? So whatever the distance that we will measure from the object to the optic center is negative in the case of convex lens. And whatever the images that we are getting, if I take two rays, okay, one is parallel to the principal axis and one more, it is passing through the optic center. Okay, see, after refraction, what it will do, it will converge at one point, correct? And whatever the ray that is passing through the optic center, it will not it will just pass through it without any deviation. So here I have taken the focus. So this will be the focus. That means the focal length, whatever the focal length that we are measuring from the optic center, in the case of convex lens, we have to take that to be positive. Since we are measuring the focal length towards the right side, so the focal length is said to be positive in the case of convex lens. And what about the V? V is also taken to be positive because the image that is formed here, it is measured from the optic center towards the right side. So the image distance is also taken to be positive in the case of the convex lens. But in the case of concave lens, what happens? See, if I take this as a concave lens, okay, it also has a principal axis, it also has an optic center, correct? And the distance of the object is always taken towards the left, so U is negative for the concave lens also. And here, if I take this two rays, okay, one that is parallel, okay, and one more I can take, one more which I will take is from here, okay. So after refraction, what happens? It will diverge, right? So if I project back these rays, you will get to meet that at one point, and that point I will take as EF, focus. So here in the case of concave lens, we are measuring the focal length from left hand side. So I have to take F to be negative. And what about the V? V is also taken to be negative because all the things which we are measuring in the case of convex lens is measured towards the left hand side. So we have taken the image or object distance to be negative, image distance to be negative, and focal length is taken to be negative. These conventions we have to keep in mind for solving the problems. Okay. And one more thing, while explaining the mirrors, I explained you about the mirror formula, right? Mirror formula. What is the mirror formula in the case of mirrors? That is 1 by f is equal to 1 by v, or 1 by u plus 1 by v. This is mirror formula. But in this case, in the case of lens, what we had to take? We had to take that as a lens formula. So it is equal to 1 by f is equal to 1 by v minus 1 by u. Okay, this is the difference. This is the mirror formula and this is the lens formula, where we have taken 1 by v minus 1 by u. Okay, next, magnification. Right. How we have defined the magnification as? It is defined as the height of the image to the height of the object. Right. Whatever the magnification formula I have given for mirror, the same formula you can apply for the lens also, with slight difference. Okay, magnification, how we can define the magnification as? It is defined as the height of the image to the height of the object. So, height of the image to height of the object. This formula is same in both the cases, right? Of the object. So if you want to write in terms of letters, how you can write the magnification as small m is equal to h prime by h. What is h prime represents? H prime represents the height of the image and h represents the height of the object. Okay, so if I define the magnification in terms of u and v, the object distance and the image distance, how you can write that as? This is equal to v by u. But in the case of mirrors, you will get the negative sign, minus v by u, correct? But in the case of lenses, you had to take the formula as v by u. Okay, all these formulas you have to keep in mind for solving the problems. Okay, next is about the power of a lens. Right, see, each lens, the function of each lens is different, correct? See, if I take convex lens, what is the function of this lens? It converges the light rays at one point, correct? See, if I take concave lens, what is the function of that concave lens? It will diverge the rays. It will diverges the rays. Okay. So, the amount of converging or the amount of diverging of the light rays is depending upon a factor. Okay. And that factor we will call as the power. Power of a lens gives the amount of converging, gives the amount of power of converging of a lens, or gives the amount of power of diverging of a lens. Okay. See, what the power indicates? Power indicates the ability of the lens, how much it can converge, or how much it can diverge. Okay, the ability of the lens either to converge the rays or to diverge the rays. It all depends on the power. Then how you can define the power as? Power is taken to be the inverse of focal length. Power is taken to be the reciprocal of reciprocal of focal length. So how you can define that as? P is equal to 1 by f. But this P is measured in terms of a unit called dioptre. Okay, this spelling is very much important. Okay. And that is denoted by the letter D. And how we can define the focal length? In what terms we can define the focal length? The focal length is defined in terms of meters. So M is the meter and D, capital D, represents the dioptry. Dioptry is the unit to measure the power. Okay, what the power represents? Power of a lens represents the amount of converging, the amount of convergence or divergence of a lens. It will give how much the lens is capable of converging, or it gives the amount of divergence or diverging power of a lens. Okay, how much it can diverge a light ray or how much it can converge a light ray. It all is studied, or it is all given by the term power. Okay, see, if I take power is equal to 1 by, here convex lens, see, for a convex lens of shorter focal length, what that represents? See, if the convex lens has a shorter focal length, it shows, it converges rays through large angles. Okay, that means the capacity of that lens will be more, okay, if its focal length is less. Okay, that is the meaning here. See, the convex lens of shorter focal length means it has the power to converge the rays through large angles. Similarly, for concave lens, if I am talking about the concave lens, if it is having a shorter focal length, it shows it can diverge the rays through large angles. The diverging power of the lens will be more if its focal length is less. Okay, that is the meaning. If they are asking, like if they are given the focal length to be less, what is the power? The power of that lens will be more. Since the power and the focal length is inversely depending, we have to say like that. Okay. And there are some problems for you. We can solve that problems relating to lens formula, and after knowing the magnification formula, we have some problems relating to that formulas. Okay, we have to solve that. What is that? First we have to read out the question properly. What is the question they have given? A concave lens. Just we have to mark the important points which we have to note down. A concave lens, I will mark concave lens. It has a focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter? Okay, from the lens. Also find the magnification produced. First, we'll write down what they have given. Okay, they have given for concave lens, correct? For concave lens. For concave lens, we have to consider the focal length to be negative, correct? That we have to take as minus 15 centimeter. Yes, minus 15 centimeter, and we have to take, they have given the image distance, forms an image, correct? So we have to take that as V is equal to minus 10 centimeter, because in concave lens, if you see, all the measurements which we have to take, that will be on the left side but not on the right side. So all the signs of the terms we have to take that as a negative. Okay, what we have to find? We have to find U. Then we have to find the magnification. Okay, also find the magnification produced by the lens. Yes, we know the lens formula, correct? From lens formula, what we know that 1 by F is equal to 1 by V minus 1 by U. So which is equal to, if I want to solve for U, I have to bring that to left hand side. So it will be 1 by u, and I will bring 1 by f to this side. So it will be 1 by v minus 1 by m. Okay. If I solve for this, minus 1 by 10 plus 1 by 15. What is the LCM? If you take, the LCM will be 10, 15, 5 2s are 5 3s are 5 2s are 10, 10 3s are 10 3s are 30. 5 2s are 10, 10 3s are 30. 30 is the LCM. So if I write this, minus 3 plus 2 is minus 1 by 30. So if I solve for u, we will get u is equal to minus 30 centimeter. So what this minus sign represents? The minus sign represents the object is placed 30 centimeter away from the optic center. Correct? So we can write here the object is 30 centimeter away from the lens. Okay. And what else they have asked to find? We have to find the magnification. Since we know the u and v values, we can take the magnification formula in terms of v and u. So it is equal to m is equal to v value is 15 minus 15 by minus 30. It will be equal to 1 by 2. Sorry, this is minus 10 by 30. So it is 1 by 3. Okay. Yeah. This positive sign of m value shows what it indicates. Since magnification value is positive, what we can say, since magnification value is positive, the image formed is erect and virtual. Okay, and what else we can write? The image formed is 1/3 size of the object. Okay, we are getting a smaller image. Okay, compared to the size of the object, the image formed will be smaller. It is 1/3 size of the object. Okay, like this we have to conclude. After writing the answer, we have to conclude. Okay, for this also you will get the marks. If you want to score full marks, you have to write each sentence. Okay, next problem. What they have given? A 2 centimeter tall object is placed. Okay, they have given the height. Tall means height. Height of the object they have given is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. Okay, the distance of the object from the lens. Object distance they are given as 15 centimeter. Find the nature, position and size of the image. Also find its magnification. Okay, first we have to write down what they have given. Height of the object. Let me write like this. HO is equal to 2 centimeter. So focal length is 10 centimeter. We have to take with the positive sign because we are talking about convex lens. Correct? So the distance of the object from the lens is 15 centimeter. So I have to take U as 15 centimeter but with a negative sign. Why? Because always the object should be taken from the left hand side. So the U value is negative. And find the nature, position and size of the image. We have to determine V. Okay. We have to determine H prime and nature. How we can find the nature? By knowing or by finding the magnification value. Okay. So we know from what we know from lens formula. What we know? We know from lens formula that is 1 by f is equal to 1 by v minus 1 by u. Correct? What we had to solve for? We had to solve for v. So with the negative sign I have to take out, and 1 by f plus 1 by u. Correct? So 1 by f, 1 by 10 plus, since u is negative, I have to take with the negative sign, minus 1 by 15. Correct? So if I solve for LCM, it will be 30. So it is 3 minus 2, 1 by 30. Okay, it is minus 1 by v. So v value is minus 30 centimeter. Okay, this is the position. Yes, here we have to take positive, right? This plus 1 by v. So it is plus 30. Sorry, we had to consider 1 by v, since we are keeping 1 by v like that, and we are moving this 1 by u to this side. So, okay, next, what is v? Okay, from the value of v, what we can say? We can write like this: the image is from 30 centimeter away from the lens on the other side. Since we are getting positive sign, we can write the image will be, image is real, okay, and inverted. Since we are getting for convex lens, since we generally get what kind of images? It will be real as well as inverted. So from that guess also you can write, or else by seeing the value of v, we can write the value, or we can write the sentence like this. Okay, we had to find the magnification. Okay, magnification, how we can find? Since we know v and u value, we have to take that only. That is equal to, m is equal to 30 by, what's the value of u? Is minus 15. Minus 15. So it is equal to minus 2. Okay. And one more thing we have to find the height of the image, right? We know m is equal to h prime by h. We know the value of m, and we know the value of m. We know the value of h, right? We can find easily. We can find h prime, m into h. What is m here? Minus 2, and h. What is the h value? It is 2 centimeters. It is 2. So the h prime is equal to minus 4 centimeter. So the negative signs of m and h, what that represents? The m and h values are negative, correct? And what that represents? And that represents the image to be real and inverted, correct? And what else we can conclude? Here the size of the image will be twice greater than the size of the object, correct? So what else we can write? The size of the image is 2 times, okay, 2 times greater than the size of the object. Okay, like this we can conclude by a sentence by knowing the values. Okay, with a negative sign and with a positive sign, you have to be very clear whether we are getting a positive sign or a negative sign. If you write this as positive and this as negative, it will not be correct, right? It won't be It won't give full marks for you. So you have to be very careful while writing the values with a negative sign or positive sign. For that, what you have to do, you have to read the question properly. Okay. This ends the video. Please, if you like this video, please like, share, and subscribe to my channel Science Sutra. Thank you. Yes, if you like this video, please like, share, and subscribe to my channel Science Sutra. Thank you. Let's meet with some more new videos in my upcoming session. Thank you.